So we'll start from retrieval augmented generation. As the name suggests, it's basically you get a like you are trying to retrieve some information. There is basically three words in it: retrieval, augmented, generation. Remember, uh, so the three basically it's self-explanatory. Retrieval augmented generation, and if you've never heard about the word retrieval augmented generation, consider this scenario that uh, you are given an open text exam. Okay. And the thing is that the only rule in an open text exam is that you will get the material to refer the answers from, but you cannot copy the entire scenario to like copy the entire paragraph as it is to the in the answer, because it will be considered as plagiarism. Although we are doing plagiarism in a way, but still, you are writing in your own words, contextual to the question asked. So, if you are being asked about how deforestation is a primal concern in today's world. Even though there is a certain of deforestation, you might still have to plug in with uh, like ozone layer and other important disaster concerns humans are facing. Right? I hope I'm right. In an open text exam, we still have to write in our own words. That's essentially what uh, agentic AI systems are doing. Sorry, retrieval augmented generation is doing. So here we have like an entire. Sorry, having a different cold, so excuse me on that bit. Yep. Yeah. So consider that like this this room full of library or like books can be metaphorically compared to all the text in the entire internet, right? And it is being trained upon like the entire sequence of gibberish and useful stuff, useful information, and garbage information from the internet. Although there are like different processes of training in LLM, although uh, like you are training the LLM to help the humans, so you will be only feeding like cleaning the data, pre-processing the data, and processing the information such a way that LLMs are able to understand and help the human beings. So, yeah, even if there are like a lot of data, but it might be a generalist model, right? It may be able to tell you how to cook maybe chicken curry. It might help you understand how the protein folding happens and tell you the basics of chess games. I mean, it can explain the rules of tennis, badminton. It can like do a lot of stuff, but is an expert. Like you have teachers in your universities who are experts in certain fields, right? And that knowledge, that particular specific concerns. Sorry, uh, is there someone who's? Uh, yeah, can I continue?
Yeah.
Yeah. So, in your university also, you might have teachers who are very experts in a very specific domain, right? And that expert knowledge in that domain helps you to seek that teach, like ask the question to that particular teacher rather than a teacher who maybe learns a lot of stuff, who's a generalist on matters. That and that builds up some kind of trust and yeah, you do not have to like think again or refer another material to uh, you basically don't have to like look for another people to get their answers, and that core principle or the philosophy is what have inspired to do a retrieval augmented generation. So you already know that LLM is able to hallucinate a bit. So you don't want hallucinated information to be fed into your application. For example, if you are building a truth search engine, for example, it's suppose there is an ideal project where you don't only want factual political news. Whenever you suppose it's like Google, but your application will tell only the factual information about a political party. You only want the factual information. But if you plug in some LLM like ChatGPT or GPT or like Gemini or like any other open source model like maybe Quen, maybe like you can go with Llama. You can go with Phi models. You can go with Dolphin models. Those are like open source alternatives, which I might show in afterwards. Uh, Even if you plug in those LLMs, it still hallucinates because it does not have a real time information of what is happening around the world. It is just like parroting what it has learned from its training data. So that is essentially when we need to have a ground truth for reference, and then based on that reference, it should like answer your queries. So I will want to start this presentation by giving a Harry Potter sequence. So uh, how many of you know actually Harry Potter? Is there anyone who I you may not need to see it, but still have heard about Harry Potter? Necessarily, you have not seen Harry Potter? Okay, fine. Uh, it's a great thing, by the way. I'm a fan of it. So I think I've not read books, but yeah, I'm not a book person, but I've seen the movies. Basically written by J.K. Rowling, one of the best-selling like sorcerer book available in the market, and basically consists of 7 books. Each one is very thick, and I don't like to read stuff from books because it's very hard for me to do it. Anyway, the point is that what if I'm taking an exam on Harry Potter and I don't want to read the entire book? Because reading an entire book obviously costs a lot of what I have to buy the book. First of all, costs money, I guess. Maybe I have to spend a lot of time reading each pages, making notes out of it, and then look at the question, compare to the question, uh, like refer to the correct character, and want to make a timeline of it. It's still too difficult for me. And like for example, if there is a question like Harry Potter and the Goblets of Fire, what are the 3 tasks of Triwizard Tournament in order? I have to like find the right page, right sequence of pages, and just l- write like look for the answers. And okay, if you're not doing it, on your own, maybe you don't want to do it on your own. Like if you're a lazy person like me, you want LLM to find an answer for you. But what if the LLM is giving a hallucinated answer? You don't have any reference to know that if it's the right answer or wrong answer. And that's when RAG comes into play. You don't give the entire book to the LLM. Suppose, let's call him an agent. You don't want to give the entire like 768 books. Like, yeah, for example, it for each book, it's these number of pages are there. So it's a pretty huge book, and maybe each of these pages will contain like around 500 to 600, maybe thousands of characters, maybe 600, 700 words. I don't know how many words it would, but compared, it will cost around more than 1 million tokens, uh, or words for easier understanding. So LLMs, uh, if you give this 1 million or like 10 lakh or 30 lakh of tokens to the LLM to process, first of all, as Munia said yesterday, it is going to hallucinate. Second, it's not going to find the needle from the heap. That's an expression that we use because it will not be able to find the exact information when it reads the entire. Maybe if you have asked the question like, what is the date of the Triwizard tournament, or how many people are attending the Triwizard tournament, and you gave the entire context or the entire words of Sorcerer's Stones into this, like to the LLM, it is going to cost a lot of tokens, so it costs you a lot of money, and LLM is going to finally not answer your question because it by the time it has read the entire conversation, your question is not even relevant at the point. So that is the pain point that we are going to solve with the retrieval augmented generation. We are only taking those very essential pages or the paragraphs from the textbooks, which is useful for us to like make a huge conclusion of. And yeah, basically, yeah, that's it. So let's look at another slide, which basically talks about uh, an example of what I have to make 2 points here. One, if it's from the same book, you don't want to give the entire textbook, even if it's the entire. chapter, you don't still want to give the entire chapter, right? How many of you would give the entire chapter? How many would you, if I ask you this question and your life depends upon it, and you have the best LLM, maybe Gemini for your help, and would you give the entire textbook to the LLM? Can I get a chat response from you? Would you give the entire textbook to the LLM so that it gets an overall understanding and based on that it gives you an answer? No. Okay. So rest of the people are going with yes. I'm assuming specific chapter. Good. Okay. Is there a better alternatives? Let's see how many people comes up. Come on, guys. It's Harry Potter, and your life depends upon it. Is there a best way? Like, let's look for some. Let's brainstorm this idea. Okay, you're not going to give the entire book. Okay, pages. Okay, which all pages? Sharma is telling she'll give not the entire textbook. She'll give pages. And how do you find these pages? What all pages? How do you find it? Just philosophy. Just think about it. Try Wizard tournament. Okay, you're going to search for Try Wizard tournament, and but okay, the question. Okay, suppose you have a PDF in hand, right? Okay, and okay, maybe I'll just try now. Uh, Sorcerer's Stone, right? Okay, Harry Potter book one. We have a Sorcerer's Stone right here, and this is 250 pages, right? And I'm gonna put Try Wizard. Wait, is it Try Wizard tournament? We have it. Let me just check. Goblet of Fire. Okay, okay, Goblet of Fire. Let me just take it. Okay, we have a copy. By the way, it is hosted by Vidya, some university, uh, some university. That's a new information for me. Try uh, yeah, we have a Triwizard tournament in chapter 12. I think Shamna will just search for Triwizard tournament, right? Shamna? If I'm looking for a holistic view, I would upload the entire, but if it's specific info, I will do a chapter. Yeah, we are going to have a specific information, right? Suppose you are a doctor and you want specific information, you won't give the entire sequence because it's too complicated for LLM to understand, right? So, Hisham Omar, I think yeah, your answer is also good. Mm, Let's refine it more. Like you are coming into this LLM era. Come on, I know you can do it. Okay. The point is, Shamna, that I want to make is that uh, here it's Triwizard tournament, but the point is like sometimes if you are programmatically doing it, you might go with Triwizard tournament like this, and it might not match the case. Sometimes it might not match the case. Like for example, if you're like putting like this, right? If you can't see, right? You're not able to see. Can you see anything like here? Okay. If I am like showing you, yeah. Okay. If I'm searching for the page in the PDF like this, it's not going to highlight anything for me. That's why it's uh, either like I am doing a word search here, but the case sensitive, it's case sensitive, so I won't be able to get the even to try wizard tournament is inside this page. It will not be highlighted, and I won't get that particular line, right? And also sometimes, eh, okay, we are doing with try wizard tournament, but sometimes I'm making some spelling mistake. Still, it's not going to highlight anything for me, right? And in that case, I don't want the exact uh, what I don't want the exact uh, word level search on it because it's going to be very inefficient. The retrieval is not going to happen. There are going to be a lot of nuances in the question as well as the answer. And what if in some page number, okay, for example, you are going to, you are having, instead of Harry Potter, again getting an entire page of uh, complex biochemistry. And in that, proteins are there, like molecules are there, and you don't know the exact spelling of that sequence. Still, you want to find something related to it. That's when we need something like a semantic searching. Yeah, I'll come into that semantic searching. Yeah. So that's when we need different types of approach, and we call it semantic searching. And this means like I am looking for conveyably same meaning. So that means if I'm Ramu is going to eat an apple and then I want to search for food, I want to get the sentence Ramu is going to get an apple. So if I'm just putting the word food itself, entirely different word, entirely maybe it's not even a fruit. But if I'm going to search for a food item in the entire sequence, if Harry Potter is the case, I want to know, okay, what did Hermione ate uh, ate in the dinner with Harry Potter, and I want to get bread and butter. But that kind of searching is not going to happen in a word level searching. That's why we need something like a semantic searching. And here, let's come back to the slides once again. And if my slide, uh, I'm going to switch often. So maybe I'll narrate whenever I'm switching the screen so that you don't get lost in where I was. So let's go back to the slide. And here, we're going to have an intelligent retrieval system. Okay. Um, this specifically means that you are going to bridge uh, the external information with the generative capability of LLM models, and it's an on-demand knowledge, which means that you're not storing the entire knowledge regarding Harry Potter into the model LLM's model memory as such, because LLM's more memory is very costly. It gives you a very bad effects if you're not in the right way. So only when it is required, the correct number of knowledge or relevant pages, just like Shabna has said before, we are loading into that LLM's memory and giving it to we are giving it to LLM to generate afterwards. So a magical analogy like ask a wizard AI about how poets rank retrieves exact book passages for correct answers. So Shamna, she said earlier that she would give the exact pages, like relevant pages concerning Triwizard tournament to the LLMs to generate the correct response, as if your life depends on it. But giving an entire page, for example, if you're taking this entire page, let's see how much words this is. It's going to be, yeah, it's huge. I think. Okay, okay, we have this much words in this, and what I'm going to do is like I'm going to okay. Before we uh, okay, we are getting a lot of words, individual words here, and we are seeing it as words. But how is LLM is able to see it? It doesn't see it as a word, right? So it goes into something like tokens. So let's go to GPT token calculator. It's called tokenizer. Let's see if it's still available. Yeah, we have it available. Yeah. So in the latest model like GPT 5.12, we have 5.12 now. Oh, we have 5.3 right now. It's the latest model. We have legacy models as well, GPT 4, GPT 3.5, which has happened from like last 2.5 years ago, and we have the GPT 3, which is the first model that they uh, ever released. So I'm selecting GPT-3 here, and the site's name is platform.openai.com tokenizer, and you can simply get this. Uh, okay, maybe I'm I will like enhance the screen for you. You can simply search tokenizer and you'll get the answer. Like for tokenizer OpenAI, you search for it and you get the first result. Just take the first look, okay? And you'll get this screen. And I'm going to paste the entire text here, okay? And it's 2600 characters and it's taking 630 characters, 630 tokens. And this is the currency of LLM. If you have like given 630 tokens, it's going to process this information and like it is going to, they are going to bill you based on the number of tokens that you're giving as input tokens, right? And here, let's see how the LLM is able to see the information. It's taking what together, happened together, two together, him, and it's taking this particular thing, uh, this particular character as a token. So you can see each token in a different way, in a different color. So that's how they calculated these tokens, okay? And they will do more steps to finally generate output. We'll see how it goes. Um, and okay, now it's taking 630 tokens. It is costly. Let's look at GPT-4. How it will how it will be different. Earlier it was 630 tokens. Now they've reduced to 604 tokens. And in the latest models, if you can see, it's just 611 tokens. And yeah, so they are able to reduce the number of tokens for the same text, which means it will cost you lesser if you're taking the newest model, but at the cost of little more money because they are more intelligent compared to the rest of the models. My point is that they have to like these kind of uh, uh, okay. Are you guys clear with what I'm doing right now? Hi, Isham. Yeah,
Hello, sir. Yeah, from what I understand is that you first try to refine the relevant information, then feed it to the LLM. This is what I got, I mean, as a guest.
yeah. Basically, you're converting the entire text into tokens and then feeding it to the LLM.
So it's more refined data to work on.
No, it's not. Essentially, that's how LLM can only process the information. So there are like, I'll just continue the conversation and so you get a more better idea. So
Sure, sure.
okay, just as we see the words in the LLM can only see a sequence of characters and it tries to give it a numerical representation of what it is about. So for generic words that we use in day-to-day life, like what happened, him, Hermione, we are getting like single tokens for this entire sequence. But look at this sequence, like don't know. This is not something that we use in a daily life. So it is trying to split the tokens into a sequence of tokens that it is able to understand. So UN is usually used as a prefix for like for unpaired, unloved, uh, unthinkable. So it is used as a prefix for some token. So this for gibberish words or like the words that we are not using in day-to-day life, it tries to tokenize it more so that the LM will understand that. The whole point of this entire sequence is that it should be able to represent this token into a numerical format. So and I'll help you visualize this entire sector. And why are we like converting the talk words into tokens and tokens into embeddings, or embeddings are what we call for numerical representation of the word, is because LLMs are only able to, or for example, LLMs are only able to understand words in numerical sentences, not an English language. Behind the scene, everything is mathematics. Behind the scene, like this is a numerical dimension, like it's a vector. This is a vector. You might have heard about vectors, right? Yeah, you might have heard about vectors, right? So behind the screen, everything is a vector, not in a two-dimensional vector, but n-dimensional vector. So each word will be represented in a series of maybe 3000 dimension vectors, each having its own attribute. For example, this bird will be considered as a vector with attributes something like dog low sound, uh, like human. It will be a mixture of lot of question answer, and that's how this embeddings would look like. Okay, and yeah, so that's how LLM understands the text that we saw in this part, and uh, the, like giving the entire sequence into the LLM is a joke, of course. We cannot do that. So essentially, we are going to give a uh, uh, particular phrases that resonates to our question. For private tournament, that would be a particular point. Like, let me just check it. Yeah. If we are talking about that, we are going to take this passage, we are going to take this passage, and we are going to take this passage based on some calculation or some semantic understanding that we do. Okay. In order to understand that, we have to go back to the slide. So, so we stop here. RAG retrieves exact book passages for accurate answer. And for that, we need deep neural network, and we need something like embedding models to find, like calculate the vectors or embeddings, and then find the appropriate passages. So let's look at what is happening behind the screen. Okay, I'm going to ask you a question. Who is the headmaster of Hogwarts in the first book? And the retrieval phase, it scans the Harry Potter text corpus. We call it, the textual data will be called as corpus in AI world, or in AI domain. We call it corpus. So text corpus for relevant passages mentioning Hogwarts leadership. And in the next phase, it crafts a precise answer like Albus Dumbledore with supporting content. Now, it's not hallucinating a bit, it's taking some reference passages, and it's going to give a particular answer, grounding its truth on the reference document. And once that part is done, uh, it has validated its answer with some of the information given from the sequence. We can expand uh, step number 4 to step number 5 by giving it additional guardrail matrices to make sure that the response given by LLM is non-toxic and non-harmful and non-politically biased thing. So we can do a lot of steps in all the scenarios. All right. Okay. And let's go to the next part. Let's look at some of the techniques that you use in simple RAG. And yeah, simple RAG is straightforward. Straightforward thing. It's easily deployable, and you can build it maybe in one day or so. You're giving you have an LLM, you have some form of data, you want this LLM to find the information for a question. It tries to get the reference document, and based on this reference document to get the answer. But in a hybrid RAG, there is a concept like sparse and dense matrices. Like uh, you kind of store the information into into a numerical format, and based on some mathematical concepts, you're going to get both these like sparse matrices associated with the data, and dense embeddings associated with data, and tries to get more accurate passages rather than just getting any kind of passage associated with Hogwarts. We are going to have leadership, Hogwarts, and only those relevant passages which is like very crucial. We are getting that information. When is it useful? When we want the exact passages, not just uh, some passages related to Hogwarts. We want exact passages uh, each time, every time. Okay, this will give an enhanced accuracy and a lot of coverage. Now we have something called agentic RAG. Now, agentic RAG is built upon simple RAG and hybrid RAG. You are essentially like giving a task to an agent to perform the RAG application. Now, this is a multi-agent system. This can take many steps. For example, suppose, can you tell me from which all uh, set does token refer to our? It is yeah, it is somewhat similar to word, just like I shown you before, but it's not exactly a word, and that is because a tokenizer is used to tokenize this, right? And this tokenizer is trained on some data, and based on this information, Tokenizer is also a kind of LLM model. Um, yeah, so it tries to split the data or the words into components it can understand. So you can say maybe 10 words is approximately 15 to 16 or 15 tokens. Okay. Coming back to the question, what were you facing? Okay. I was going to ask you like from which all departments are you in and which all, can you give me a overall idea about where you are? Which all department and yeah,
I am in my second year PG in linguistic department.
great, great, great. And some other departments in mathematics, from uh, from like sociology. I'm not sure. Okay, I'm just asking. I'm doing BBA, future studies, nice. Can I have a little bit more mathematics? Nice. So for this example, I'm going to use Hisham, Nandana, Nasrin, and Ankwaza. I hope I'm sorry if I'm spelling that wrong. Okay, and all of you are from different branches, and Hisham is from linguistics, Nandana is from future studies, Nasrin is from BBA, and Ankwaza is from mathematics. Suppose I'm going to ask you a question regarding Hamiltonian distance. Who is the one who's going to maybe trying to get more accurate regarding Hamiltonian distance and regarding algorithms, maybe cosine similarity, embedding similarity? Come on, chat.
That would be Anquasa, I guess, because he's from mathematics.
Yeah, great. So uh, he is the one who's going to specialize in that field. He has information. He has textbooks about Hamiltonian distance. He has textbooks about vectors. He has textbooks about how to compare two vectors, maybe like do a lot of operations. Okay, a lot of operations. So he's going to be an agent. Nazar is going to be an agent regarding BBA. Nandan is going to be an agent for future studies, and Hisham is going to be someone linguistics. I'm really sorry. And you are all AI agents. And when I'm giving you a particular, I'm going to ask you a very generic question. The LLM should be able to this multi-agent system. You are all multi-agent, and you will be able to um, maybe break down a very complex question and give it to uh, like if I'm asking question concerning NLP and mathematics, maybe Hisham can do one of the tasks and Ankosa can do some other task. And based on your information, the final agent or the supervisory agent system or the supervisor, maybe yeah, the lead system will be able to combine the both answers together and then give you an output. That's something called agentic RAG system. You're not defining a pipeline based on the input. It can it can like uh, okay, understand. Okay, to which all agent should I give the information and which all agent should do which all task. That kind of autonomousy, when introduced in a RAG approach, is something called agentic RAG. And then there's something called graph RAG, which is a very less explored uh, RAG approaches. And if people going to do research based on RAG and graph RAG, this could be like very innovative solutions. Because yeah, uh, when you're going to give data into RAG approaches, you are storing that into something called vector databases. And I'll show you the approach. Mm, sorry for that. Wait. Yeah, here I'm going to. We have a traditional database, which is like SQLite database or like relational database, and uh, here I'm going to like store information in rows and columns, like students' age, students' class, students' marks, etc. Maybe in transactional database, transactional data like bank statements, how many money is being transferred, so on and so on. But we need something like a vector database. Vector database is a specialized database used in retrieval augmented generations to store specific type of data. And the specific type of data specifically includes something called embeddings. And embeddings are, it's a vector data, it's a multi-dimensional space. So it's a vector actually having multiple dimensions, and which is optimized for AI and machine learning. And these databases are specialized to perform operations significantly faster to do these mathematical operations together. Okay, and yeah, they are very good at doing similarity searches. And yeah, so what we are essentially trying to say is that we need specialized database for storing this information. Uh, yeah, I think we have covered all this, right? We have uh, okay. I think we have covered this part, single track part. Do you want to have you still understood this hybrid track approach?
Sir, can you give like short three, four sentences summary like, for someone like me who's not computational and is not good in like these things yet? So, like general concept. Maybe it's, if you can break it like some like summary of general concept in few sentences, I
Yeah,
really appreciate it.
yeah. Sure. I'll try to do that. So, like we saw yesterday, maybe I'll try to show you some examples online. Let's go with sparse and dense metrics first of all. Let's go with images because images can talk a lot of. So, yeah. Oh, sorry. This is a very okay. Let's go with this thing. Yeah. Suppose this is a everything is mathematics by the way, so it's better. You understand the maths behind, so you get understanding of how LLM actually works. So, the LLM would uh, each token that we said earlier, I think here, right? Each of these words will be translated into some n-dimensional vectors, which is this can be treated as one vector with two dimensions. So we have like n-dimensional, maybe 200, 2000 dimensions, and we will be storing the information of that particular token into a numerical format. And into a numerical format, and there is some uh, sometimes we don't need to have this much information or like lot of numerical data about a particular word. So we try to take only those required fields from or required information and make a sparse matrix out of it. Sparse matrix is nothing but with lot of zero values inside this. Okay, so essentially we are getting very pickpocketed or like very cherry picked information as a matrix. We are combining both of these informations together to retrieve the right amount of information or right amount or accurate information from the entire vector databases, right? So we are getting information based on keywords. So keywords and dense retrieval will help you get information more semantically. And keyword based searching and semantic based searching together, if fuse, we'll call something like hybrid tag. And based on the information, we'll get a set of quality passages of Harry Potter, and we will be using that for generation. Uh, yeah, I hope I hope I've explained it. Uh,
So, sir, just to make sure that I understood, like you use the
yeah,
sparse one first to highlight the relevant sections, and then you use the dense uh, to get more detailed information. Like, did I
yeah,
understood it?
yeah. For example, name like Hisham wouldn't. wouldn't have a semantic meaning associated with it, right? For example, maybe like a word like Shamna, Nandana might not have dictionary meanings associated with it, right? So in order to get passages related to Shamna or Nandana, we need to have like a keyword, like keyword based searching also. For that, we will use the sparse retrieval method to have a keyword oriented searching. And there are like a lot of other techniques that we can use. Like I'll show you a couple of things. BM25, best match 25, BM25, best matching 25. It's like a searching algorithm um, based on term frequency, which is like keywords associated with it. And this can be used as a sparse retrieval methodology. Dense retrieval, we use embedding models to find you the relevant documents, and we'll combine these two, make a fusion of the embedding models, and then get the corresponding response and generate accordingly. I hope I'm clear right now. Yeah. Okay. Is there any other questions associated with it? Okay. I hope I'm clear. Moving on to the next part. Okay. Maybe today we'll all build the RAG system on our own. I don't know. I'll show you how my thought process works when I'm building a RAG from scratch. Not scratch, yeah, but yeah. And we've explained the agentic RAG once again. So here, let's look at the research applications first. Okay. Uh, we have a complex research workflow with multiple information sources. For example, as I said earlier, Hisham would be more into linguistics. Nandana would be more into BBA or future studies. So each will have expertise in their own domains, and we need to fetch the information from each of the respective domains. And this part, this kind of complex research part requires some kind of orchestration or autonomous program level executions. So for that, we need something like agentic RAG. So it's basically a clone of human, but gives you information on a particular domain. And it will have a characteristic like it will be multi-hop question. Like a simple question or like a complex question can be atomically divided into individual independent questions, and then it can be answered by the particular domains. For example, even if let's go back to the first question answer section. Here I was asking the simple question. Now, if it's too simple, let's. What if some questions like this happens? How does Sirius Black's reputation change from Harry Potter and the Prisoner of Azkaban to later books? Now, this kind of questions requires me not have me having to refer Prisoner of Azkaban novel as well as maybe Half Blood Prince, right? Maybe I have to check on all the books later, Prisoner of Azkaban, to finally conclude how Sirius Black's character development has happened, and that requires me to like have multiple knowledge bases or knowledge sources to finally give an information. So that what was I am trying to deliver here. Like I have to split the questions into multiple part, associate each question to a responsible knowledge source, and then finally get an answer. Then we have tracing narratives. Like yeah, if we are going to have multiple books or multiple knowledge sources or documents, we have to like what uh, yeah, get the information from the corresponding resource and then combine it together, and that's what I was going to explain here. Now let's look at a very interesting thing that personally want to uh, what explore in my future. Maybe if I'm building an application, I want to do this. This is a very good thing, as it's self-explanatory. It's a RAG, but based on something like graph. Why graph? Because graph represents a kind of mathematical model. It gives you information, but it gives you a relation between two vertices, right? For example, if my name is Alex, that word itself, or like if that sentence itself can be deconstructed into kind of vertices and relationships. Like my name, it's my, and the name is that part is going to be a relationship, and Alex is going to be another node. So I can draw a vertex from my to Alex with a relation of name. And uh, if there is another sentence like my father loves Alex, like father loves Alex, it's another node, but gives you interconnected of the all knowledge. So we call it knowledge graphs uh, nowadays. And yeah, let's look at how one builds a knowledge graph from the ground up. We are going to construct a node and adjust from text purpose. Example, character relationships in Harry Potter. So Harry Potter is a friend of Hermione, and Hermione is a wizard of maybe, yeah. What was the name of thing? Hogwarts, right? Yeah, he's a student of Hogwarts, and we have clubs like like Gryffindor. For teachers who have not, for faculty members who have not seen Harry Potter, please forgive me. I'm trying to associate it more in a funny way. Uh, please pardon me. So it's going to build some relationships, and this is specifically going to be very interesting if you're building something related to research like chemical compounds. Like you want to connect hydrogen with oxygen, um, and then you have to like connect some other nodes together, and these kind of graph structure contain some information, and then you can traverse this graph structure and give it corresponding answer. This can help you find information faster than a semantic search if it's properly done. Another important application of GraphRag is that, for example, if I am having a document, I think it was yesterday, Harida, I think you were the one who was working on KCB, right? Who was doing some
Yes, yes, sir. I am working in KCB.
KCB, yeah. So I think in KCB you have a lot of documents, and each of the document will be referencing some other documents, right? Maybe the consumer number yeah, is a reference point of the details of the customer, and maybe uh, each field in that bill or any document will be referencing some other document, and that document will be referencing some other document. So in that perspective, if you get the source document, you can you can like traverse in depth into other pages that are relevant, and then find the corresponding answer. And for that we'll have uh, graph knowledge bases and tools like Neo4j. Like, let me show you what it is. Neo4j can be used. This is a graphical knowledge basis, and this will help you like sort out a lot of problems related to relational database. If you can associate a node with some relation to some other nodes, then this kind of application software or tools can help you build some amazing applications together. And you are not just searching for some meaning, you are actually reasoning over the connections. You are like, uh, you want this information, okay, you're going to go in depth to the other nodes and connected nodes associated with it. Like you're going to analyze the relationship, not isolated files, and then finally you're going to generate answer. uh, so the key advantage is that you are not solely depending on semantic searching, which is like similarity searching based on meanings, uh, over a huge corpus of data, because you don't have enough control over it, right? This is more like a driven approach where people uh, like w- will try to associate some kind of relation between two nodes and then traverse the entire nodes to find pinpoint a particular node each and every time. So hallucination won't be there. It will be fast. It will be reliable. There are a lot of good reasoning towards it. And yeah, I think I've covered this part. It's basically the difference between traditional database and vector databases. And let me show you. I think Hisham was the one who was interested in this part. We have seen uh, we have seen something like uh, tokens earlier, which is like a subword. But then I also showed you like dense vectors and sparse vectors. And the vector embeddings looks like this. It's like a I hope it's visible, right? Is it visible?
Yes, sir, it's visible.
So each of the word or each token will be represented as a n-dimensional vector, and each of these, you look at this kind of float values like decimal values, and this will be each of this together represents an idea or a concept that a token represents, and you are going to have a textual data, and when a query comes, you have to like embed it using an embedding model, which is also an LLM model, and then you have to like convert that into vector embedding. So output of the vector embedding model will be a embedding model will be a vector embedding, and then you're going to store into a vector database. Vector, yeah. Is there someone? Okay. Oh, we are going to design document management system for handling all documents. Need to know the points to be taken care in that. Sorry. Okay.
Okay, can I speak now?
Yeah, yeah, sure.
Okay, as you told now, KCB has several documents. Actually, they are many documents are interconnected. That is, some legal points we have to refer for some consumer reference. Like that, there are so many interconnection between these documents, and each documents will be uploading or downloading from another departments. Okay, we have several departments also. So now we have a plan. I'm working in the IT department as a software developer, and there is a new proposal for the document management system. That is an application where we have to keep a repository of the all relevant documents in KCB. And the concerned official has to upload or download data from documents from there. So, can we have any tools that is helpful for the director sector? The director sector, which I means like you told now, consumer data, relevant data are there, the billing information are there, and other related documents will be there based on the regulation, tariff, etc. So many different documents are there. So, as you told, how can we interlink with these documents? If there are any tools that we can configure these directories so easily so that everyone can understand it and make use of it. I think you get my question, or I will ask you later after the session.
No, no, it's perfectly fine. So I think Arita, I'll just rephrase your question and let me know if I've understood the question correctly. So you're working in KCB, and you have your task as a software developer is to make a repository and make sure that uh, the documents are interconnected to each other. And whenever an LLM, you're giving a question to the LLM, you're going to correctly fetch the right document. Is
Yes,
that right?
yes, yes. The users may be new persons joining in our department or somebody like that. So there must be an easy that in our help document we know when we put a question, they show the relevant topics there so that they can easily find out what is in their mind. They can select from the choices given there. So for easy arrangement, not easy, but a proper arrangement, so that everyone can look into that and get the right thing from the right place. So this Neo 4G, I think Neo 4G has the thing though that I will check. Okay, thank you.
Yeah, I think we'll have a concession on it. Maybe I will need to have a little more information regarding how the data is being organized. Because
We can have it after the session, sir.
yeah, cool.
We can
Because
continue.
yeah,
We
I think
can
it's a
continue it after the session. After this,
yeah. I think the main point that I want to bring about this particular application is that you will not be able to process the all kinds of documents, uh, like all kinds of documents. Documents can have like different structures, like structured and unstructured and different types of structure, right? So you have to find a way to organize the data in the corresponding way that the graph rag will take the input. So you have to maybe define the relation between, yeah, okay, this document has the reference document to this document, and like that you have to build the entire graph, and that's going to take some time. But once that's built, I think the rest of the information, the rest of the thing can be great. And also uh, please try to start from very simple part, like take a very subsystem of subdomain of documents first, or documents related to one or two departments first, and not all documents first of all. And then you have to like make a initial approach and test it out first of all, and then only scale it. Okay, otherwise it will be very difficult for you to encompass all the kind of data structures. You have to have a structured study about how the data is being organized, and also how are you going to extract the data from these documents. I'm just curious. Harida, I think get down. Okay, you are downloading the document, but how are you going to extract the information, the text data?
Actually, that is meant for the uploading and downloading the relevant documents. That is, there are several orders. There are several government orders, several board orders. There are, as you told now, there are relevant legal orders. So many kind of orders are there in KCB. So when a person, someone who is doing the tax related operation will need the documents related to the finance act, like that. So
Yeah,
someone tariff and commercial being need the tariff gazette and the the regulatory commission orders, like that. Okay, so when someone invests into the DMS, they can upload and download data. So as you told, we have to branch each week. We have to analyze a study based on the various departments and the various documents they are handling, and we have to make a directory structure first. Then we have to incorporate it with the Neo for the I think.
yeah, I think that would be a good approach.
Okay. Okay. Thank you.
Harita, but just for a pro tip, I'm just
Okay.
giving you a tip. Like when you're even having a lot of corpus, like a lot of PDFs together, the PDFs can be scanned and unscanned as well, right? It can have digital copies as well as something which is
Yes,
scanned.
yes, we have digital copies as well as the scanned copies has to be uploaded.
Yeah, yeah. So, for example, if we go into the code, so for example, if I'm having a KCB document, uh, KCB, okay, I'll just expand it so much. So,
Supply code. From the code, there is a supply code, supply act. There are so many things. Supply code 2014 it is available in the net, or the supply act. There are so many documents, large and small orders. Many things are there.
yeah. So, for example, if I'm taking some data from, for example, um, I'm taking this entire thing and then copying it here. For example, we have like documents like this, right? And this is KCB policy one textual document, and uh, since it's like extractable, you can like make enough data. But what if it's like a scanned document? You need some way to like extract that information first and then feed it to the
No,
feed it.
it's required to see the PDF document. It's required to see the PDF document. They have to download the PDF document. That is not editable by that person who are downloading it. That's
Oh,
what.
but I think that would cause a different way of handling things, because yeah, essentially uploading and downloading the file, that's okay, but then you have to extract the content based on different policies and everything. What you can do is that I think you can like link the different file names together to form new folder, and then based on that information you can. I think that's perfectly doable. I hope I understand. Like based on the different file names and file departments, you can like interconnect these different
Okay. Yes.
PDFs and then find the relevant information based on it.
I will connect to you whenever I need some help after this session also. So, okay, thank you. Please continue. The time is done. Okay.
Yeah, no worries, no worries.
Okay.
Thank you, Agatha. Thank you, Agatha, for raising the question. Yeah, let's go back to the thing, what we're explaining. So we were explaining about embedding a vector database, and once we have the vector embeddings, we'll be storing it to a specialized vector databases. And vector database can look like, there are like a lot of examples for vector database, like something like, I'll put in the chat. There's something called Chroma DB. There is something like Vice. There is something like Pinecone. There's something like a lot of things. Chroma DB, the database. Uh, Let me just do a quick search of the database. You have like something like Qtrend. You have something like Milvus DB. So these are the different specialized databases that you can use in your application to build the vector database. So as a what I represented here is like the vector database, and you have to substitute the corresponding vector database with your preferred one, of course. I would say like Qtron, Melvis, Pinecone, everything is really good. ChromaDB is a very lightweight model that you can test it out on your own. If you're like people who are into programming, you can take this ChromaDB. And yeah, I think once this vector database is installed, you will have to have some sort of vector operations. When a question is being queried, it will go into the like who was the maybe the mother's name of Harry Potter. That will be again the English language will be converted into a vector embedding by a embedding model, and that will be that query embedding will be looked upon the vector database, and once the relevant chunks is being retrieved based on the search, like this circle represents that, and that particular query results will come back to the application. The LLM will infer the response and give you an augmented generation, and that's the whole part of that's the working of how LLMs and vector database are bound together to give you the development or the programmatic angle of how it works. And then we have like in research fields how it's useful in biomedical legal analysis. So I think there are people who are building legal analysis reports where when you ask a question earlier, you need to have a specialized what advocates, lawyers to give you point like BMS Bharati analysis, maybe point number A, point number B regarding a problem that you're facing. Now you can do it with LLM. Even biomedical research, for example, if you are dealing with a very niche area of biomedical like regarding protein folding or maybe creating a new medicine, uh, like you can use RAG in your proprietary data to find those information. Like you have Google always, but sometimes if you're working in some very confidential environment, you don't want the data to go outside. You don't want your confidential report to go outside. Okay, so you can make a RAG agent, and then when you're asking the question, you can found its relevant topics from the report and give you question answer like answer. For education purposes, it's more like a personalized tutor experiment. So you can if you are having a textbook about what, let me guess, system softwares or engineering or like linguistics or like social engineering attacks or anything, you can social engineering attack is not a bad thing. Okay, it's something related to ethical hacking. It's a hacking technology or hacking method, social engineering toolkit and stuff. So you can feel that you can make a database of the entire personalized. You can make a graph DB of vector database of the entire textbook or your syllabus, and then like you ask your question to the teacher, you can ask the database or the application, okay, what does social engineering toolkit mean? How does Hamiltonian distance and tell me another kind of distance. Sorry, Hamiltonian distance. Maybe tell me the difference between Distract's algorithm and like give me a what is the difference between NP problem and NP hard problem. Since I'm a part of computer science, I'm getting all these keywords. Sorry that I'm not getting in the domain that you are in. So it's like a personalized teaching. So if you are going to do some projects, this could be very good. And for literal analysis, for example, you are working in a scientific domain. So there is a website called Connected Papers. I hope it's still working. When I tested it, it's still working. And this is for research scholars and people who wanted to find the papers that are associated with your particular thing. When I was checking, for example, let's look at LLM and reasoning. And I'm just putting a uh, random paper solutions, and I'm getting something like judging LLM as a judge. And this paper will have reference to other documents. Okay, this is a graph approach they are taking, because each of these particular document will have reference to other documents as well, and the documents which will have larger citations or larger connections uh, will have what more nodes or bigger nodes, which had like bigger applications will have particular nodes. And what I was going to trying to say is that people who are into research fields, if you have like a lot of connected papers associated with it, and you want to get an insight, to get a pattern, or to find a particular solution to a problem that you're facing, you can take all these documents and download it, extract its text content, and then make a RAG LLM agent, find an answer based on all the different things that you're seeing. I hope I'm clear in that segment, right? Can I have a thumbs up or thumb down based on your understanding? Yeah, cool. Someone's thumbs up in exploring. Cool. So yeah, that's on something, and I think you can refer to this site whenever you are free. For research scholars and other people, this could help you. And coming back to the topic, I'm just closing this tab. Closing this tab. Let's go to the application site. And then, yeah. Uh, okay. I think these are all what we have explained earlier itself. Um, so I just want to have a summary. Before summary, I just wanted to, yeah, once this is complete, I'll just go to the hands-on session. Okay. So summary: retrieval augmented generation. You stop LLMs from hallucinating. It tries to make up its own inaccurate responses. You give it a grounding truth reality, and then based on this grounding truth reality as a reference point, it tries to generate some responses. It will have a reduced bias. So LLM, the foundation LLM models, uh, the foundation LLM models have a particular problem. It's trained on an unsupervised way. Okay, unsupervised way. No one is guiding it to learn what it is learned today. So since it's an unsupervised methodology, it tries to lean more towards uh, social stigmas or stereotypes. And so yeah, we used to see that Indians speak in a particular slang, Indian slang, and in Hollywood movies, like okay, that's kind of biased. And similar to that, only the information that it sees, the LLM will be able to remember, and we can reduce the bias with up-to-date information, um, uh, without any political unnecessary like friction. You can make a straight factual answers every time, and then it's dynamic. You can integrate it with modern technologies, because most of the AI technologies that we use have inbuilt track systems associated with it. Now let's look at some of the uh, mm, let me- I wanted to like show you some. Okay, can we have a small break? So I have like only one more slides to complete, and maybe we'll be coding a little bit laterwards. So what do you say if we take a small break right now? Okay, we'll take a small break right now. I'll drink some water and come. Like 5 to 10 minutes. It's okay. And during that time, I can also prepare. Wait. Okay, guys. Let's be after 5 to 10 minutes. Wait. And I think coordinators, once they are free or people want to start again, you can like message me. Uh, I hope that's great.
Yes, sure, Mr. Alex. We'll come back maybe in 5 to 10 minutes.
Thank you so much.
Thank you, sir.
Hi all. Should we restart this? Okay, let's wait for some time so that other people will also be there. There are thumbs up exploding there. I hope my audio is already clear. Looks clear. Okay. Okay, maybe we'll start in 2 minutes. Maybe you can search up what's vector database and what's embedding if you're not understood. Maybe do you have any some questions for meantime? 2 minutes. Okay. Okay, so maybe we'll start the session right now. Share my screen. Okay, not going to be, okay, I'll be sharing a link for you. It's a Colab research. It's a Colab file. I hope you'll be able to, I hope you are seeing this. If you are having access issues, let me know, okay? We'll go through a step-by-step thing of what's happening here and then try to get an answer. Is a hope you are able to open it up. It's a very simple track, and tomorrow I think I'll make sure that I make a rack system and with an MCP with a lot of papers and a lot of research papers connected, so that I can show you like real life example of how this works. So it's accessible, and the only thing that you have to add here is that in I think cell number 2, yep, you have to configure your API key, and I think the coordinators have already given you some guidance on how to create an API key. I think I've covered that in session 2, I guess. So you have to go to Google AI Studio, search it up. You will find an API key session. If you're logged into Google, you'll get into this page, and you'll get you can copy it from here, okay? And then you have to go back to the Scholar page, paste it here. So this would be something like a setup. So in order for this information to work, you're going to have some packages installed, and if you're new to programming, we are going to use something called pip. Pip is a Python's package manager. So how pip works is that it tries to install all the like dependencies of Google Generative AI and whatever Gemini. We are using Gemini for this particular approach, and the tools and dependencies and functions related to Google Gemini we will be getting from here. We'll be using something like FICE, which is the vector store that I think I've shared in chat already. And then we are using something like NumPy. I don't think it's useful, but yeah. So the first session, let me just connect it to real quick. We can connect from here, and then once it's connected, it'll show you a tick mark here. Yeah, it's connected. Now I can see the resources as well. Now, the caller by default, I think it shows you resources, show you system, RAM, and disk as well. And if you want to, like, currently it's having a CPU quota, but you can also change the runtime. If you want GPU access, you can go to here and then change runtime type to T4 GPU. They are providing V5E and T4 GPU for your hardware acceleration. And once you select that, you can save it So instead of 5 CPU, you can use GPU version. Okay. And yeah, I'm going to start. So I'm first of all installing all the requirements that I need. So once all the the package is installed, then I'm going to like configure my API key, which is crucial part of this is a password for getting access to the Gemini models. Okay. And I'm configuring that part. Got it. And once that part is done, I'm having a document. Okay. So consider this as a Harry Potter's entire novel system. Okay. Like 500, 600 pages, all the entire system of Harry Potter novel. And here I'm just using a dummy paragraph. So this in real life would be like 60,000 paragraphs or like 2,000 paragraphs or something. So we'll extract the text from the document and we'll have some in a variable. And we'll have to chunk this document into, I think yesterday Munia took chunking. Did she take chunking? Did Munia yesterday take chunking? I was not in the entire class. Or should I explain the chunking part? So it's not something very hard. It's just you are just splitting sentences or words into maybe like into a particular limit. Say 150 words into a particular chunk. So if you get a whole lot of paragraph or an entire page, you will chunk the sentences into chunk the entire page into 5 or 6 segments. Okay, based on the word limit. So that is a function that we are doing here. We are going to chunk the text. So input text will be document and chunk size will be 150. So based on sorry, I'm waiting on a second. So based on length of the chunks, we are going to chunk the document and return the based on some parameter. We are going to return chunks in a list of words. So here, if I run this application, I'm getting 4 chunks because this is being chunked into 4 different categories, and I can also make a new cell here and show you what the chunks are like. Chunks look like. So it looks like this. You can see it consists of a list with 4 different sentences. Okay, 1. Here it's 2. Here it's 3, and here it's 4. Okay, this is a very basic chunking. Okay. The problem is that for in a particular chunk, you're not getting the entire context. Are we getting the entire context here? Guys, thumbs up or thumbs down? Are we getting the entire thing here? No, right? Because after and your next chunk is only the next chunk is only next chunk is the continuation of the other chunk. Ideally, in a situation, you need sentence-wise chunking. You need to like chunk based on sentences or based on if like you encounter a full stop, you have to chunk from that area. Okay. In real life situations and production grade system, you want to chunk like based on a complete idea or like we call it atomic, right? So we get the chunks. Now we are going to have a model for embedding, and for embedding we are using the embedding models given by Gemini, which is Gemini embedding 001. We have, I think, the latest model is Gemini 004, but still we'll be going with Gemini 001, which is a neat model for embedding, right? And then we have to embed the chunks, each chunk separately with the Gemini model, right? And let's see how it goes. Now we are going to embed the model with the particular chunks. We are invoking the get embedding function with the corresponding chunks. We're getting some embedding shape like 4 chunks with 3072 vectors. Like each of these sentences represented, each of these sentences is represented into a n-dimensional vector. Now let me show you what this n-dimensional vector look like. Okay, well, let's go to the embeddings and I'm going to take the first sentence here. This is the first sentence. And in computer language, it's zero. Starts from zero, not one, right? And I'm going to print it for you. It show you a number of what numerical values. Yeah, it show you a number of numerical values. This is how the vector should look like, right? And this will be an array. Uh, this is like vector, and this is the numerical representation of this sentence. Okay, and then what I'm gonna do? I'm gonna yeah, total vector index. Yeah, now I'm going to yeah, here it's just um we have installed something like files here, right? It's files CPU, and we're going to store this document. Sorry, if I'm being too fast, please let me know. Coordinators, if you're getting messages from the audience, please let me know. And once I've created the embedding using the get embedding model, this function, I'm going to transfer entire embedding models into something like files, which is a vector database. I think we have talked about vector database here, close to here, vector databases, right? This is the engine that we use for semantic search. Semantic search means meaningful searching. And how are we going to find which topic is similar to which topic? That's how vectors come into play. That's how these embeddings come into play. If two, like king and man, if two words are there, king and man, those two are kind of similar to each other, right? And a king can be represented as vector man plus vector power. So I'm going to show you that's what, like, king equal to man plus power, right? This is the representation. This is the representation, king equal to man plus power, and this vector can be close to, not if even if it's not same, it is somewhat close to man and vector of man and vector of power, or embedding of power, right? That's how the semantic similarity works. Okay, and we are not going to run this because this is not a Python program. And here I'm going to index this thing into the embedding models. So once that's indexed, we are going to write a function for retrieving. And for retrieving the process, we are going to search. We are creating an index here, and with the index of the vector databases, I'm searching the query embedding. I'm also embedding the query, embedding the query, and getting the top two elements. Here I'm defining the top into two, and I'm getting the top two chunks responsible for related to my query. And query is the question that I'm asking. So I'm getting some number of chunks, which is two chunks I'm getting. And once the chunk is received, what I'm going to do, based on a query, I'm getting some chunks, and these are the retrieve documents. And in the context, this is the prompt part. So you have to give instruction to the LLM that answer the question using the context below. That is context. Context is what your ground truth or the reference document, and the question is what you're asking as a question. And the model will finally give you an answer. Let me see if it works. This is the exact flow of this. And once the definition works, we are going to use Gemini 2.5 flashlight, and I'm going to ask what is RAG. Okay, and based on this information, I'm getting some response. So answer is RAG, retrieval augmented generation, is a technique that combines retrieval and generation. And suppose I'll show you a funny example. Suppose RAG session by Alex School. Okay. So my new document is like this. I'm going to chunk the document again. I'm going to create a few chunks, and based on the models, I'm going to get embeddings and then store the data into a files data set. Okay, once all this is finished, I'm going to maybe ask who took the session about RAG? About RAG. Let's see if the answer comes. Here I'm getting Alex. Are you able to see it? Sorry. Are you able to see it? Okay. Yeah. So I think that's how the RAG. I'm getting specified documents, and um, based on this document, the LLM. If I am not giving this thing right here, for example, what? Okay, Harry Potter is the favorite book of Alex. Since this information, I'm not processing it, like I'm just editing this document, but I'm not storing it to the corresponding files database. Okay, so even if I'm adding it to the document, if I'm asking like what's the favorite book of Alex, it still wouldn't say. It probably say I don't know. I don't know. Let's see what the LM gives you an answer. Based on the context provided, there is no information about Alex's favorite book, right? So since we have edited the document, we have to chunk the document again. We have to store the document into what? We have to get an embedding, and we have to store the database here. We have to store into a files database. Rest of the queries may not be changed because that we are not like actually that's definitions. So, I mean functions, so we have to change. And now if I write the queries, what's the favorite book of Alex? It should probably say it's Harry Potter. Yep, that's how a RAG works. I hope it's clear. So behind the scene, uh, when we are like calling this function, like index.search, what it's essentially trying to do is that it tries to compare our query embedding, which looks like something like this, with all the query embeddings, uh, yeah, with all the other query in here, and it tries to get the top two closest queries to our. And how does it find the closest query? And that's by something called cosine similarity. And for mathematical students, they might know, like, let me just, sorry, um, cosine similarity. And there is a function called okay, there's a formula called cosine similarity, and this is a mathematical base of what's happening inside the files database or any vector database. So I'm getting a query. I'm trying to find the closest angle. I think more than the equation itself, I think it would be easier for you to understand image. Yeah, because an image is like 100,000 words. So there is a vector A, and then if there is a query with embedding inside a Fice database which is closer, and if the theta is lesser, it means they are more related. And if it's like larger, it means that it's not related. And we can find the most related. With theta value lesser, we'll find the most closest embedding model, and then we'll take the two of the most similar ones. That's how it works. So I think I've covered a little bit of it. I think I've 20 more minutes. Okay, now since we have covered uh, like some protocols that list surrounding this agentic world, and yeah, I'll show you a slide regarding that. I think I've covered this in a depth. Let me see if I've covered. Where was it? Yeah. It's not going to be a technical deep dive, right? Um, so I was going to talk about something like model context protocol, MCP and A2A protocols, and how it's useful in our systems. And uh, for the people who are not into computer science, protocols is the word we use, simply means which simply means there is it's a rule, and based on these rules, models and uh, LLMs communicate with the context or the documents or the text or anything. Okay, and let me have like a small break once again. Okay, I think the screen is okay. Yeah. So the why we need model context protocols and modern protocols for AI is that uh, ev- everyone is creating their own LLM models. Everyone is creating their own agentic frameworks. Everyone is creating their own knowledge bases. But there is no kind of uniform standard by which people can communicate. If you are a developer like me, there are like millions of ways on how to connect one thing with another thing, like a knowledge base with an agentic system. You literally have to like code it all over again. So it's very difficult for us since we don't have a uniform agreed upon standard by which how we are going to communicate in a LLM with the context. You need some kind of standard protocols. Once again, so yeah, um, yeah. So that's why we need some common integration tools and common protocols by which every LLM can talk with every other knowledge bases in the most standard and unified manner. Consider like this: like you go into an institution, and if the institutions like if a university doesn't have any rules and everyone comes, every people come from every other place with different languages, different cultures, and if you are there's no way by which people can communicate with each other. You cannot talk with the faculty uh, like in a standardized way, right? It is going to create a lot of fuss since you don't have an agreed upon rule or a protocol. And that's when we need a standard protocol. Like LLMs, all LLMs, whichever provider, even if it's Anthropic, even if it's Cloud, even if it's something like Olama, VLLM, that's like OpenAI, Gemini, every LLM should be able to communicate with a knowledge base in a standard approach. And that's when model context protocol uh, context comes in play. So we have model context protocol is the first ever protocol that comes into play of agentic world, and it was introduced by Anthropic, a team behind Cloud Opus Cloud. It's a platform like ChatGPT. I can show you that as well. Cloud. This is the landing page of Cloud. I hope you can see it. It's similar to Gemini with ChatGPT. Developers, I think they love. I know it's still a white screen. Let's wait for it to come. It's taking a lot of time. Yeah, this is the clothes landing page, and these are the people who. It's similar to ChatGPT, but they specialize on some very interesting domain. Yeah, you can try Cloud for free. You can just Google, sign in Google. I'll show you what it looks like. Continue.
It's simply like ChatGPT, but it's, I think I love it. I mean, you can configure different models they provide here, and you can connect your. The most important part of uh, this cloud is that you can connect this model with different sources. Like you can connect it to Slack, you can connect it to Excalibur, you can connect your GitHub account, you can connect with anything like Gmail or something. Uh, Gmail, like there are different tools that you can connect it to Hugging Face, you can connect to Ira, connect to different things. And you can connect to Canva and help Canva build some amazing stuff. Canva is like a designing thing, so you have to like it will connect based on some protocol. And that protocol was invented by or like introduced by Anthropic, the team behind Claude. And it's a standard, open standard protocol engineered to manage different AI models with different contexts that across different platforms. And it's a middleware layer, which means that these kind of you don't have to know about the middleware. It's just how data is being represented when it's been transferred from LLM into a knowledge base and knowledge base to LLM. It's secure and traceable, meaning that the data is encrypted and like it enables a safe way by which you don't even if you like provide you don't want LLM to access your every information, right? You only want LLM to get the information uh, of a certain privilege. For example, you're creating an LLM, you're creating a RAG application, and the student's agent should not get access to all the teachers' materials, right? So you need some kind of access authorization security that is given by MCP, and then it's LSP inspired. LSP is language server protocol used for coding languages, and yeah, it the model context protocol has taken its philosophy from LSP. That's the main part, and let's look at how MCP works, context aware communication. So, okay, let's start from the very basic. It will have awareness about who's talking, like which user is talking. For example, you are creating a chatbot, and in that chatbot application, I can log in, Nisaj can log in, maybe Sriraj can log in, and Sham can log in. A lot of people can log in, and all of us are in different categories, in different departments, and with different privileges also. So I should not be able to access the important files of Nisaj, and Nisaj should not be able to access my confidential data. So it is this MCP works on users and session ID and authenticated states, which means that only the right person can access the right kind of information. This is critical in if you're building some projects for healthcare segment like hospitals or some like creative licensing or something. You should authenticate users always, because most of the informations are confidential and you have to keep the privacy. It also, even if it's sessional based, it can keep historical contexts like who said what. That question will be covered by MCP. And next part is also, if I'm asking something related to mathematics, I think Nandana should. Sorry, was it Nandana or okay, I'm supposing Nandana is from mathematical department. So I'm asking something related to get mathematical documents, and that particular if I'm asking a question like I need information related to uh, Hamiltonian or cosine similarity, I should only invoke that particular function that gives the information of that factor. Context intent should be understood, and that particular portion has to also to be included in the model context part. So that are the three main part MCP covers, and yeah, it also gives rich metadata, which means that you kind of get who said what at what time, what privileges, what was the history, what was the context. Since it's stored in a persistent storage, means that it's stored on disk. You can get all the information data regarding your queries and what was happening when MCP server is being connected. Um, so data is being it's not something huge. Like MCP leverages JSON RPC, which means that um, there are like 2 or 3 different types of ways by which MCP servers tries to communicate with your LLM model, which means that uh, JSON format simply means a dictionary pair. I can show an example of dictionary pair. This is a JSON file, so every data will be stored in itself as a uh, key value pair. This is a key and this is a value. Okay, and you don't have to know the working of it. I'm just saying that okay, whenever something happens, the data from the data towards an MCP server and from an MCP server will be following a JSON structure. Okay, you don't have to know a lot about it. Let's look at some real world examples. So if if Flipkart is giving an MCP server on their server, like uh, I can simply connect that MCP adapter to my whatever client, like my agent, and then ask the agent directly. Okay, I need a suit less than 10K, blue color, and size should be 42 in plain language, and the LLM would be able to communicate that with the Flipkart server, and Flipkart will give its response back, and agent will translate that thing entire thing and give it back to me that yeah, these are the different options that you have. That's the real world applications of MCP. Why? Okay, can't we have MCP? Yes, you can't. You can still communicate even without MCP server. But MCP server makes a standard protocol such that even if I make the agent with LangChain, LangGraph, Groove AI, Agentic AI, any other frameworks, and with any other language models, I can still communicate with the same MCP server, like same endpoint. That is something as a developer, it's something very useful for you. Now, this is what I've explained in the last part. So, MCP versus traditional API integration. In traditional API system, you want to change how the function works. Like we've made a retrieve get document or retrieve function earlier, right? That particular function might need to be rewritten for another LLM framework like Llama Index, and maybe another agentic system like Crew AI or Let AI. And for all of these different implementations, I need to code it again and again. But MCP, you write it once and you can do like connect it across different agents. That's the beauty of MCP. Basically, it's like a C-type adapter of different what you have different mobile from Apple, Samsung, Huawei, Motorola. But when you want to connect with the adapter, charging adapter, you connect it with the C-type charger, right? Similar to that, the data flows in a very standardized manner. I hope that I'm clear for that. So uh, like like I said, Anthropic uh, gave it in Q4 2024, and they launched it as an open standard protocol. Not they didn't keep it to themselves. They like standardized it everywhere so that other LLM companies and every other framework they can adopt this protocol, and it got its open source momentum, traction, and later, like we said, Neo4j, LucidWorks, and all the major technological giants adopted these approaches and gave their clients an MCP service through which they can communicate with their data. And yeah, now people are actively developing that protocol so that they can right approach. Um, yeah, it's simple. I'm sorry, maybe I'm taking too much. I think I'm going to wind up. Now. So as a conclusion, it's an MCP is a backbone of next generation AI integration. A lot of problems related to interoperability will be solved in this particular manner. It is actively transforming architectures in the most context-aware way, and how LLM knowledge is to be transported from LLMs to vector databases, vector database back to user in all a very standard manner. So that would be main part of it. Mm,
Yeah.